Welcome to 100 Days of Code with Here. My name is Richard, and I'm a developer evangelist with Here Technologies. This week in 100 Days of Code, we will be looking into the Here Transit API. So this video will be useful to you if you're looking for solutions to days 91 to 95, but also if you're just generally interested in our Transit API. If you don't know what 100 Days of Code with Here is, check the link in the description. This will lead you to a blog post which will get you started on your own journey with 100 Days of Code. All right then, let's check out task for day 91. Our task for this day was to generate and display a public transit route between the Singapore Zoo and the famous Singapore Merlion. Now, because we need to display a route on the map and we need to call the public transit API, I've created a simple project here with a basic interactive map using the Here JavaScript API, and I have created a simple fetch call that we can use to get a transit route and then display it on the map. This isn't something you haven't done before in other days of 100 Days of Code, so we will not look into this in too much detail. What we want to look at in detail is the public transit API. So let's go to our developer portal, developer.here.com. Let's go to the documentation, scroll down, find the transit API. And there we want to go to the API reference. The first thing we need to call the public transit API obviously is the API URL, which we can find down here. And we can copy this and straight away we can paste this into our fetch. Next thing, we want to scroll up and we want to check out the parameters of the public transit API. And we'll see there are two required parameters, origin and destination. And these are just latitude and longitude coordinates. So what we got to do is we got to get the latitude and longitude for the Singapore Zoo and the Singapore Merlion. And in previous weeks of 100 Days of Code, you've already used the routing API, and you'll probably recognize sort of how this works, right? The routing API also had an origin and a destination parameter. And in fact, the way this API is designed is to try and match the other mobility APIs that we have, including routing, as much as possible. There are obviously differences because the use case isn't the same, but in this case, origin and destination are identical. So how do we get a latitude and a longitude? Well, a good way to do this is to wego.here.com and simply search for what you're looking for. So we're looking for the Singapore Zoo. And we found that here, and you can just click anywhere on the map, click on that, and then under See More Info, you will get the latitude and longitude. We've got our parameters down here, so let's have a parameter we'll call origin, and we'll just paste that latitude and longitude in there. And we also need a parameter called destination, and we'll do that too. And similarly, we can just search for the Singapore Merlion. And again, we can just click here on See More, and it'll get us the latitude and longitude. Now, what we also need is an API key. To get your own API key, you can just go to the developer portal and go to the top on the main page. Click on sign in and get your freemium key. Because you're on day 95 of 100 Days of Code, I assume you've already done this. So I'm just grabbing my own, which I've already got here for the Maps API, putting that in here. And then we need to do one more thing, because this will call the Transit API, but it will not yet give us a route we can draw on the map. So calling this would give us information on the route, but it would not give us something that we can draw on the route. And similar to the routing API, which you've used, there is a return parameter here, and that allows us to customize what kind of data we'll get in the response from the Transit API. So in our case, what we really want is to get the polyline value so that it gets us a polyline back, and then we can go and draw that polyline on the map using our JavaScript API. So we'll add the parameter return, and we say equals polyline. And then we're already done with our API call. What we can do is we can very quickly see if we can run this and see what happens. And actually, before we do that, let's fix my little typo here. Let's call it polyline as it should be. And then we probably also want to do something along the lines of console log response so we can have a look at it. Let's fire this up. And then we'll go into the developer tools and have a look at the response. And again, similar to how the routing API worked, we've got a list of routes here, and we've only asked for one. We'll ask for more in a later day. And inside the routes, we'll have sections. Now, again, if you remember the routing API, that also had sections within a route. However, it works slightly different for the transit API, where for the routing API, you would get sections for intermediate waypoints. For example, if you had 3 waypoints, then the first section was between the origin, the first waypoint, and then the second section was between the first waypoint and the destination. In this case, the sections are separated into different modes of transit. So you can see for each of the sections, we'll have a type here, and it says pedestrian, transit, pedestrian, transit, pedestrian. So you'll walk from where you are to the public transit station, probably a bus station, and then that will take you to the destination station for that route. And from there, you'll walk to another transit station. You'll get on a bus or a train again. That'll take you to your final station. And from there, you still need to walk a little bit to get to the actual spot we picked on the map. And you can also see we've got the polyline information in here. So what we need to do is we need to go into the routes, iterate over the sections, and for each of the sections get the polyline information, and then draw that on the map. So let's go and do that. So we'll start off by creating a new HMap group. This is really just a little helper that will later allow us to get a bounding box around all of our polylines. This is simply a logical grouping for any kind of map object, including the polylines that we'll be drawing. Now, we'll go into the response. From the response, we'll grab our routes. We'll just grab the first one. We know there is only one right now. From there, we'll grab the sections. And then we'll say for each of the sections, we'll just iterate over those and draw on the map. What we need in order to draw a polyline is a line string and a style. Now, the transit API, just like the routing API, returns a flexible polyline, which is a compressed form of data that allows us to handle long routes much more efficiently. But the good news is that the JavaScript API has a very nice helpful function in it that will automatically let you convert a flexible polyline to a line string. So we'll create a line string here, and we'll say hgeo.line string from flexible polyline. And then we'll just say section, give me the polyline. Then we'll create a polyline. So we'll just say polyline new HMap polyline. And we'll pass it the line string. And then also we'll add a little bit of styling to it so that it's better visible than with the default style. And all we're really changing is we're making the line width a little bigger. And then now that we have the polyline, we'll actually add the polyline to the group. So we'll just say round group add object polyline. And now we should have a polyline for every single one of our sections added to that group. Now, what we still need to do is add that group to the map. by adding the group to the map, all objects inside the group will be added to the map. So now that we've done this, they should be visible. And another thing we want to do is we want to make sure that the map is showing the entire route. And this is why we've used a group in the first place, because we can get a bounding box around a group of objects and then tell the camera to focus on that bounding box. So we'll say map get view model. And we'll say set look at data, which is how we tell the camera where to look. And then we'll tell it, hey, please use bounds and use the bounds from the root group. And there is a convenient function get bounding box available here. This really is available for most map objects and so on, including groups in the JavaScript API, which is really, really nice and useful. And we've made a little mistake here somewhere, and I think we simply forgot the new keyword here is my guess. That looks much better. Let's close this, and we'll see we have a map of Singapore. The Singapore Zoo is up here, and the Merlion is down here. So we very nicely have a route. And that was our task for day 21. A lot of the stuff we've done today we'll be able to use in the next couple of days, so things should be a little bit faster. So let's finish day 91 and look at what day 92 brings. So for day 92, we were asked to create a public transit route again, this time in Berlin between Alexanderplatz and Checkpoint Charlie. But we were also asked to ensure that we arrive at this destination before 9 a.m. in the morning. And we also need to request at least one alternative route. So the first thing we need to do is we need to update our origin and destination to the new locations. I've already looked those up. So I'm just going to quickly copy those in here. So now we've got to go into the documentation and check out what kind of parameters are available to satisfy those two requirements. And we immediately find arrival time, which allows us to define when we want to arrive. And conveniently, the very next parameter in the list is the parameter alternatives, which is number of alternative routes to return aside from the optimal route. So I think we'll just add those two parameters to our existing API call and see what happens. So let's say we'll add the parameter arrival time. And we'll say today is Wednesday, the 22nd of July 2020. So the way we'll write this is we'll start with year, we'll do month, we'll do day, and then we'll have T as a separator, and then we'll add the time, which in our case is 9 in the morning. And then we'll add alternatives, and we'll say alternatives. We were asked to request at least one, so we would add one. If we add one, we'll get the original route, but we'll also get one alternative route. So if we called 2, we would get a total of 3 routes. And if you remember from yesterday, we got an array of routes in the return. Yesterday, there was only 1 route. Today, if we set this to 2, there should be 3. And that should really be all we need to do for today's task. So let's see if we did everything right. Let's fire it up. Now, if we look into the response, we'll see that now we have 3 routes in our route array, as we expected. So we have fulfilled the requirement to get at least 1 alternative route. In our case, we've gotten 2. And then if we look at one of the routes, we can look at the sections, and we'll actually see, if we look at the last section, we'll see that our arrival time is 8:58. Now this is cutting it a little bit close, but it exactly meets our requirements. We want it to be there at 9 and we are there at 8:58. And of course, whenever we define an arrival time, what we really generally want to know is when do we need to leave in order to be there on time. And in this case, it would mean we'd have to start walking towards the public transit station at 8:41 in the morning. So we've got alternatives, we got an arrival time, and that means we've met our requirements for day 92. Let's look at day 93. So for day 93, we were once again asked to create a transit route, in this case in New York, between the Empire State Building and the American Museum of Natural History. We were also asked to avoid the subway, display the fare prices for the rides, and make sure that a route does not contain more than 2 changes. So changes between one bus to the next, or a change between a subway train or a bus, and so on. So let's have a look at this. First thing what we need to do once again is to change the locations, the latitudes and longitudes. I've again prepared this already. You can look this up for yourself if you like, or just use mine. Those are the Empire State Building and the American Museum of Natural History. We can remove the arrival time because that's no longer a request. We can also remove the alternatives, but we have to add a couple of new parameters. If you look to the right, we can immediately see the parameter changes. Maximum number of changes or transfers allowed in a route. So in this case, we'll simply say changes equals 2, and that should do what we want it to do. Then, in order to get the fare prices, we can once again utilize the return parameter. And you'll see we requested polylines as additional data the last time. This time, we'll simply add fares to the list. So now we'll get a polyline and the fares. And then finally, we want to avoid the subway. And there is a parameter for that called modes. This really allows you to filter which types of modes you want to permit and or avoid in your route. By default, all modes of transport are available. You can either just make a list of those transports you want to permit. So for example, if you were to say modes equals bus, subway, then you would be requesting a route that only contains buses or subways, but nothing else. Or alternatively, you can subtract. So you can say something like minus subway, and that would mean that all modes of transport are allowed except for the subway, which is what we're looking for today. So we've got our route, we've got a maximum of 2 changes. We want to make sure we don't use the subway, and we've requested to include fares in the response. So let's save this. Let's fire it up. This looks good. We've got a route in New York. That kind of looks like it makes sense. Now we can also look into the response again. Again, in this case, we only have one route. If we look at the sections here, we'll immediately realize, yes, there are only 2 changes. We're changing from pedestrian to transit and then from transit back to pedestrian. So this is less than 2 changes here, so we're perfectly fine. Our requirement here has been met. And then we'll look into the transit, and we'll see the mode here is bus. This is the only transit we're using, so we've successfully avoided the subway as well. Now with all of that done, let's look at day 94, where we were not supposed to build another public transit route, but instead find public transit stations near a given location, in this case, the Tower of London. For that, we need to go to the station search resource in our API reference, and we'll go and we'll copy that. Our API key can stay the same, though all of our other parameters essentially have to go. For us, we really just need the station options and query station by location. And there we'll see there's an in parameter which is required, specifies the center point and the optional radius of your search. And all we really need to do is we need to use the in parameter and give it the location of the Tower of London. As always, I've prepared this. And all of the other stuff here about drawing routes is probably not that useful. However, since we need to draw the stations on the map, we probably need some markers, and it might make sense to just create a marker group. And for the rest, we'll delete this. We can use this at the bottom here again. We can add the marker group to the map, and then once again we can use that marker group to get a bounding box and set the camera. Now, let's comment this out for a few seconds because of course the bounding box will still be empty because we haven't added any markers to it. And let's just look at the response we're getting from the API. We've got our object, and there we see we simply have an array of stations, 1, 2, 3, 0, 1, 2, 3, 4. If we click on this, we'll see that the station is in fact called the Tower of London, stop TA. We get a location with a latitude and longitude in, and that's really, I think, what we need in order to draw the marker on the map. And again, there's other information here, types of station, location, and so on. So we've got latitudes and longitudes for all of those stations, so it should be pretty easy to get those. So instead of iterating through sections and drawing routes on the map, we'll simply iterate through stations and draw markers on the map. So let's take the response, and in the response, let's say stations, and let's do for each station, we are going to create a new marker, new h.map.marker, and that needs a location as a parameter. So that's easy for us. We can just say station place location. That's what we want. So station.place.location. And that's a latitude and longitude, and you can take that right away. That works perfectly. And then we'll just say marker group, add object, and marker. And that should honestly be it. So we'll save this, fire it up. Let's reload this to make sure the bounding box works properly. And we'll see, we've got the Tower of London here in nice 3D, and there are our markers. This might actually be like a ferry or a water taxi station down here. That's kind of interesting. Okay, so that was pretty simple. And we've already got day 94 finished. Simply use the station search feature and add markers to the map. All right, day 95. Today we want to display the departure board for a very specific tram station. We were supposed to do this for the Cavill Avenue station in Gold Coast, Australia. And by departure board, we really mean departure board. You know, when you arrive at a public transit station, it has this little board that displays the next trains that are departing and how long until they're departing and where they're going. All of that information you can get from our public transit API. And if the city supports live public transit, you'll even get live delay information and all the kind of things you would expect. To use this, we once again need to switch resources. We need to get to the next departure resource. And we'll see that if we click on board option, we have the option to query departures by location. So we can just feed it a location and say, show me the departure board for the nearest stations. Or you can say query departures by ID, specifies a comma-separated list of station IDs. And in fact, every single public transit station in our database has a unique ID. And so since we were asked to get the departure board for a very specific station, we should probably use the IDs parameter here and feed it the correct ID. Now the question is, how do we get that ID? Well, actually, we can just use the station search from yesterday. If we, in fact, fire this up again, and we look into the response that we've gotten, we can actually see that for each of those stations, we have the unique ID delivered. So this station is 420-321-352. So what we want to do is we want to get this for the Gold Coast in Australia. So if you once again go to here we go, we can search for Cavill Avenue Station in Gold Coast, Australia, and we'll see that we've got a location here. That kind of makes sense. We'll grab this and we'll just feed this new location into our station search from last time. That'll work just fine. And we actually see this is probably the station we're looking for. So if we open up the developer tools again, Cavill Avenue Station. And so now we've got an ID here. We'll just write this down, 425315170. We will remember this. And then we'll go back to next departures. We'll grab the departure resource. We'll copy this into our code. And instead of in, we'll use the parameter IDs. This is a comma-separated list, though in this case we have only one ID. We'll just use that here. And of course, we need to now delete all of the stuff about markers. We don't really need this, but we'll keep the console log. We've saved this, fired this up, and we immediately see here in the response, we've got a list of boards. Because we've only asked for one station, there is only one board in the station. We get kind of meta information around the station, name and type of station, even the ID gets passed back to us. But what we really want is departures. So we have a list of the next 5 departures. And we're seeing the agency, we're seeing its translate, we're getting a URL, we're getting the departure time, we're getting we're seeing that it's a tram, so light rail mode, the correct colors for the local transit agency, and so on. Now, one more thing we were asked to do is to make sure that we only show the departures for the next 30 minutes. So if we go back to this, we'll see there is a time span parameter, which we can add as well. And that limits the responses to that specific time span. And this is just given in minutes. So if we say time span 30, and we go back here, we'll see that if we go into all boards, instead of 5 departures or 6 departures that we have earlier, we now have only 4 because they're only for the next 30 minutes. And that's it. That is a quick overview of the solutions for days 91 to 95. And a good overview of all of the 3 resources in the public transit API: routing, next departures, and station search. So thank you for sticking with us. Only 5 days to go. We'll see you next week.